This is a video describing the naming of alkyl halides. These molecules are created by taking a hydrocarbon and taking off at least one hydrogen and replacing it with a halogen. Now, this doesn't typically occur in nature, but there are lots of modern uses, for example, as coolants or plastics like PVC. And the naming of these is really straightforward. Based on the halogen that's been added, you would use a group name, either fluoro, chloro, bromo, or iodo, with the appropriate rules for naming them as groups, as if they're a branch. So as a simple example, let's have a look at what happens when methane undergoes a sequential substitution. So one at a time, we're going to take off the hydrogens that are on the methane molecule and replace them with chlorine atoms. The chlorine at this point acts like a branch, so we're going to name it first, and we're going to use an appropriate root name for that, so chloro. So in this case, we would call this molecule chloromethane. The second molecule, once you get the second group in there, needs an appropriate prefix to indicate that there are two of them. So in this case, dichloromethane. We just keep going. In this case, if there's three chlorines, trichloromethane. And then once you have all four that are there, this becomes tetrachloromethane. So on to some examples. You can actually have mixes of different branches. And so what I intend to show here is what happens when we have multiple halides, or maybe a mix of halide and alkyl groups. So in the example on the left, I have a 3-carbon backbone that's illustrated here. Then I have groups in these locations. In terms of naming, between the chloro and the bromo group, we name them alphabetically, so the bromo would come first. However, they have equivalent significance in the molecule, so we just want to produce the lowest numbers possible. So that makes this carbon over on the right carbon 1. So to name this properly, what we would do is go 2 bromo, 1 chloro, and then we name the backbone propane. Okay, so nothing terribly extravagant there. Now, the next molecule is a line structural diagram, so let me kind of walk you through that. We have a 4-carbon backbone that sits here. So just to illustrate, I have carbons in these locations, and then I have a methyl group that sits down here, so that's going to be addressed as a group. And then the fluoro is actually out here, so a lot of students misunderstand that this bond also represents another carbon somewhere, but it actually is the covalent bond that joins the carbon to the fluorine. Now in this case, I have a methyl group and a fluoro group, and even though it doesn't matter, I'll just bring it up for the sake of saying that the equivalence of these two is important. Again, we're trying to do is just produce the lowest numbers possible. And so the carbon over here is going to be the first carbon of the chain because it's the one that has the groups closest to it. In this case, we have the fluoro group that comes alphabetically before methyl. Okay, so in this case, I will name this 1 fluoro, 2 methyl, and then butane for the backbone. All right, so lastly, the molecule over on the right is a little more complicated and has a 4-carbon backbone as well, but it has a methyl group, a chloro group, but then also a double bond. And as far as numbering goes, the double bond will take precedence over any of these. So it's important that the double bond gets the lowest number available to it, and then everything else will be numbered based on that. So if we have a look, the double bond actually is on the second carbon either way you look at it. Okay, so if you kind of look from the ends, the double bond is equal parts away from there. At this point, what we can do is default to the fact that the lowest numbers would be created by having the chloro then get the lowest number, considering that the double bond is going to be at carbon 2 regardless. Now, alphabetically, for our group names, chloro is also going to come before methyl. So, putting this all together, we get to 1 chloro, 3 methyl, and then but 2 ene. Okay, so I hope that explains a little bit about naming of alkyl halides, and there will be more naming videos to come.